All right, I think I got it, guys. I think I got it. I think I did.
Hey, Red, can you post a scene in here?
All right, gents. So right now we got a live stream. This is like a part 2 from the part 1 of the flat Earth discussion we had the first time around. I've got some people on here from the flat Earth Discord who are in there pretty often. I'll probably get some links into chat throughout the time here. Pretty much going to go over their side and what their findings and all that stuff is. So without digging too deep, this would probably be about, I'd quote it about an hour and a half or so, but we'll see based on how into it we get, how deep, and say how involved you guys are. So mods, you can allow debate and things like that. Just anytime it gets overly toxic and too deep into the personal attacks, let's squash that with a quick timeout or a mute or something like that. So yeah, we'll jump into it in 1 second. So like I said, we've got about 1, 2, 3, 4, 6 people from the Flat Earth Discord. We have, starting off, we have Indio, we have Ron, Karen B, Jose, and Bong is their Discord names, abbreviated for some because some are longer than others. But I'll jump right into it and pretty much start off with the intro. Then we'll move into some discussion about the science behind it, and then go into the more government findings, things like that. So all right, guys, whoever wants to start off, I guess we'll start just in a line. We could start with Indio, just how you got into it, when you realized, and your history within the flat Earth community.
Yeah, excuse me. I got into it like 3 years ago, just randomly. I was looking for geometry problems between spheres and planar geometry, particular solution to it's called the plane wave equation. But when you start punching in plane and sphere in YouTube, you get I was getting all this flat Earth recommended stuff, and I dismissed it. And but eventually, after a couple months of getting spammed that basically from YouTube, I eventually watched one, thinking it was going to be ridiculous and I was just going to have a laugh. And I'm not laughing now because a lot of the information I saw were things that are impossible on the globe or in the model itself. The first thing I looked for when I decided I was going to really investigate it was, is there a direct measurement of the surface of the Earth? And to my surprise, this is something nobody's ever done. And you'd think after, a couple thousand years, someone would actually try it, but no one's done it. I mean, now people have done it. Flat Earthers has done it, but before that, no one had ever done it. There's also a lot of other impossible things, like we see too far, we make observations that are impossible. Then there's things like the properties of water, is that water is always level at every scale that we can measure. There's a lot of evidence that convinced me that the Earth is in fact flat.
Okay, so you pretty much, you were kind of pestered to take a look at videos, and then, once you finally did, not thinking you would jump into it, you kind of were enlightened into the world.
Yeah, that sums it up pretty well.
All right, awesome. Ron, what do we got, buddy?
Oh, yeah. How I got into this, just it was showing up on my suggested videos list of all, I look into a lot of conspiracies per se, 9/11 and things like that. And I kept seeing Flat Earth coming up on my suggested video list. This is before YouTube had the algorithms turned against us. It was more fair. There was a guy named Barry Satoro, and he was investigating some things like false flags, and not just him. He wasn't into the flat Earth, but there was other people I respected, and they kept talking about flat Earth. And I'm like, I really respect these people's opinion, but I kind of think they're a shill because they think the Earth is flat. And I mean, now I've done a total 180. Now, if I trust what they're saying, except that they think that there's secret space programs and things, then I think they're a shill. I'm like, it's totally flipped. That's like my litmus test to tell if someone's legit, because not everybody is going to know the earth is flat, but if someone is too smart not to know, I suspect them. My BS detector goes off. So like I said, how I first got into it, it was showing up on my suggested list. And then one night I thought, you know what, let me watch this just for like shits and giggles. I was, having a few beers. I'm like, let me just see what these retards are talking about. I thought it would be something funny. I'm like, well, let me just get a laugh out of this. But then I started searching like all the proofs they were giving. And it turns out I couldn't debunk any of them. Like, one after the next. I'm like, what's going on here? And then I saw these pictures and videos of planets and the moon and things like that with the Nikon P900. I was seeing pictures of Chicago across Lake Michigan, people taking pictures of oil rigs, like videos of oil rigs. Yeah, I lost you for a minute.
Yeah.
They were way too far to be seen. They were doing like they were mapping them out on Google Earth and saying, look, here's this oil rig. It's like 25 miles away, someone at the beach in California, and they were zooming in on it. I'm like, wait a minute, like maybe these guys are faking it. Like the odds are there's some randoms on YouTube that are faking it, but what are the odds that like NASA and the Russian Space Agency, what are the odds they're all faking it, but these couple random nobodies on YouTube are telling the truth? That was my dilemma. So I went out and bought a P900, and I was, just
on a whim, like you went out and bought on a whim kind of thing.
Like 2015, around 2015, and then 2016 I bought the camera. I'm like, I have to know before I go out on a limb and I start telling all my friends and my family, hey, the earth is flat. I was seeing all the proof, but I couldn't believe what I was finding. My cognitive dissonance was telling me, no, this can't be true, can't possibly be true. But then everything else that we observe, like we don't feel any motion. You look at all the way the stars move, and the sun and the moon, they all move the same direction, east to west. And then there's one central point, Polaris, and that one star never moves. It's like the pivot point like on a record, like a vinyl record. Everything revolves around that central point. And it just so happens that central star is right over the North Pole. So it all works out on a flat Earth map.
Okay. All right, that makes sense how you got into it. Similar way. Like I feel like all it takes is a quick trigger and some in-depth research. I think from what I've talked to, but because I've talked to you guys a few times, and that's what it seems to be. It seems to be like okay, let me see what this is about, and then a little digging, and then you're digging deeper and deeper and deeper and stuff like that. So
it was by accident. Like I didn't set out to become a flat earther. I set out to like debunk it. First it was just for laughs. I'm like, I'm gonna prove these assholes wrong.
Okay.
This is stupid. Because I was into science and all that stuff. I still am into science, but I've been reading it since I was a kid. Popular science. I was a big Star Wars nerd. I loved all those space movies.
Yeah.
And to me, it was like finding out Santa Claus is fake. It was like it turned my world upside. It was terrible.
Yeah. All right, cool. Karen, if you're there, interested here because I haven't heard from you before from last time. I know some of these guys were. How'd you get into it?
Yeah, my story is actually very similar to everybody else. I had somebody on my Facebook feed posting flat Earth stuff, flat Earth videos, and I thought, no, man, that is just really stupid. You've just gone too far, because I, like everybody else, I was already looking into other deceptions, as I like to call them, because I don't really like I think conspiracy theorist is sort of a derogatory term, but there's other deceptions that I was looking into. And so when this flat Earth thing came up, I thought it was just really stupid, and I didn't even want to click on any of that stuff. One day I was really bored, so I did click on it, and I thought it was going to be funny, just like Ron said. And then at the end of the video, I was not laughing, and I was like, wow, some of that stuff actually is making sense, and it made me very curious as to why they would be saying this stuff and what the answers were to some of the things that they were saying. And this was back in 2015, and there really wasn't, there was nowhere near the amount of flat Earth content that there is now. So back then I was just sort of on my own pretty much, because I remember we would wait days for a new flat Earth video to come out. Now it's like all day, every day they're coming out. But so I went to like NASA.com and or NASA.gov and space.com, and I just started trying to find the answers to all these questions on my own. And like everybody else, I couldn't debunk flat Earth. I still can't. So.
Okay.
But I can find plenty of things wrong with the ball.
Yeah, I feel like maybe because like the age of technology, the lack of media sharing has evolved. That's why you saw this, like you guys were saying the other day, it's grown exponentially. The community, I believe that's why. It's because the ease of access of media and things like that. Before that, there was nothing, like you said, or lackluster material. So coming out and showing all this stuff, you have, there is no censorship. Well, not much censorship as far as, what you put out anymore. So even though maybe you guys think there is, I'm not sure, because specifically we'll get into that later towards the end. But, that's an interesting observation, I think. So yeah, then we got Bong. How do we work it out, man?
Yeah, similar story too. Like Ron said, I was researching, and Karen said I was researching some other deceptions, and I enjoyed Rob Skiba. Rob Skiba, I thought he was a pretty, he's a cool guy. I respected his work, his research. Then he started talking about flat Earth, and then I thought he's lost it. And then I talked to my friend about it. He was looking into moon bases, the Nazis. So I looked into the Nazis, and that led me to Antarctica, which led me back to flat Earth. And then I had to make sure, like, all right, is this a thing? Is flat Earth really a thing? Like, and I looked into it, and then finally I was like, all right, the only way I can be sure is to go to NASA. So I go to NASA, look at their photos, I look at the moon landing, and then I look at the launches, and I was like, surely there's got to be a launch. It shows a continuous shot, going out into space, and there was nothing. And then I determined that NASA is hiding something, that they are. And then I had to find, are they hiding something other than the flat Earth? And then I realized they are hiding the shape of the Earth or something. And that's what after all the tests I did myself too, but I had to make sure that NASA was lying. Not lying. And once I realized they were lying, that's when I figured out that there's something going on here, and started looking into it some more. And then I realized, hey, I'm learning so much more practical science, just researching this stuff than I ever did in high school or college, from science. And yeah, here I am. Yep. That's my story.
All right, awesome. I think the best way to do it is, like, if you guys could explain, any one of you can pick this up first, but if you guys can explain, because I think most people have the idea that when you talk about flat Earth, you're thinking the world is a plate and we can fall off the edge. There's like a rim. Like when people think flat Earth, that first thing that pops in the head is like we're living on a disc. And I think that's one thing that the first thing you need to understand is that's not the belief at all. You're not just living on this one. Well, it could be, that's not the, the end all. So what exactly is the concept of the flat Earth in more detail than just, we live on a plate? Okay, that doesn't make sense.
I think it's the word flat. That's what I think. Because when I came to flat Earth, I didn't like the word flat Earth. I just wanted to call it Earth.
Okay.
So I think the word flat automatically conjures up that image, in people's mind. So I think it's just word play. I think they intentionally wanted to use the word flat Earth rather than just saying Earth. Versus the globe. The globe, they just call it Earth, and then they would call this flat Earth. I think it's psychological.
Yeah. Now, potentially, could the Earth be a globe, but our instance of it, our area of it, is a flattened area like that? That's what kind of, last time I was talking with you guys the first time around, that was the one thing that, in my mind, struck out to me. Like, I also was like, they believe the Earth is a circle plate that we live on, a flat Earth revolving around whatever, so once I realized that no, it's just we live in potentially a biome on something else, on something, you know, bigger or whatever it is. You know, we don't know exactly what it is. It could be anything. You know, that's kind of when I was like, oh, I see what they're saying here. Like, you know, not just, it's not a globe, but it's, you know, it could be anything. It could be a globe even, like I said. Just the unknown of what it is past that.
Yeah, it's kind of like if you strip, like, because we have theories, right? And we have scientific knowledge, things that we absolutely know for certain, right? That anybody can test. They can test in their backyard, they can test in their garage. But then there's the theory, like scientific theories, which are kind of testable, kind of not, a little bit wishy-washy. And if you go to, like, what do we really, really know for certain? We believe that the Earth is flat. We believe that we've measured it flat. We think we know that for certain. Now, what the boundaries or the limits of it are, we can't be sure. And why the sky appears to act the way it does in relationship to the Earth, we aren't sure of that either. But the best way to know the shape of something, right, is to just measure it directly instead of inferring things by looking at, like, indirect measurements, right? So you look at Polaris and you move some distance and it shifts in your view, and you can infer, you know, that I live on a globe because Polaris moved a certain amount. But if you take a tape measure and you measure the Earth flat, what are you supposed to believe? Like that indirect measure or your direct measurement? So we kind of believe that, you know, you should start with the direct measurements and build from that. You know, it could be a larger globe, I guess, but everything else would be messed up. So like all their distances of all the stars, planets, the orbits, the masses, all that stuff would all have to be like reworked or re-engineered. You know, I also want to talk about the flat dinner plate thing.
Yeah.
I think that's part of the, like, kind of like part of the propaganda, right? So when you're a kid, they tell you, well, them idiots in the past, man, sailors used to thought they'd sail over the edge of the earth or run into sea monsters or something, right? So that's kind of like part of it, to convince children that that idea is stupid. You know, no one's going to sail up the edge of the earth. No one's ever done that. That's ridiculous. So if you think the earth is flat, you're ridiculous too. That idea comes as part of teaching the globe in the first place. It's not like an idea that people originated out of their mind, right? If you take the universe, even in like the standard model, no one knows the bounds of that. And we don't claim to know the bounds of the earth. Is it infinite? Is there even such a thing as infinity? Is there an edge? All those things. We hear these questions every day. And we're not going to sit here and say we know everything and we know the exact dimensions of the earth. We only know for certain that the surface of the earth is flat, and it's something that we're all going to have to deal with. Why it is, as just a basic scientific question. Why are we seeing this? Why are we measuring this? It doesn't match all our other observations. So why is that? I think that's kind of the fundamental question.
Okay. Yeah, that's the kind of like I said, I think that's one of the biggest things that is automatically assumed is the dinner plate. So that's why I wanted to, you know, when I, you know, was learning about, you know, everybody knows, even you guys know, I'm not a flat Earth believer at all, but that was one of the things that was
something that had to convince me too. Like, well, how does the sun, like, how can we go around a flat plane? How does that work? You know, and if you look at the map in a little different way, you know, that north is in the center, and, you know, you travel east and west in a circle, but not in around a sphere, around a surface, the same way you'd like go around your house. As soon as I realized that it was possible to do it that way instead, it opened up, you know, the rest of the possibilities, because that's like the first hurdle people have to overcome is how do you go like from New York to China? How does that work? You know,
yeah,
a simple question like that.
Mm-hmm. So what about these tests? What are the tests that you guys, like the backyard tests that you guys are talking about, that were brought up? Like, what are these tests that you're talking about that can be tested? I know we've talked about them before, but I just want to like hit back on them because I know one of them has to do with like distance and light and line of sight and stuff like that. So,
oh, Karen, you want to cover that? If you like.
Well, distance, that sort of thing, that all sort of depends where you are geographically and how, what sort of line of sight that you can have. Like stuff like that is really good to do over bodies of water, large bodies of water or on the coast. Because then, we have charts that tell you, how much curvature there should be in X amount of miles. And so past a certain point, things should just not be visible due to it being on the other side of the curve. So if you can find a spot that that allows you to see, the farther the better, 20, 30, 40 miles, and you get, a high zoom camera, or even if you just go on a clear day, even with a regular, like a pair of binoculars or something, you'll be able to see things that you shouldn't be able to see. Other things you can do in your backyard, you can, when there's a full moon, you can measure the temperature of the moon, and you'll find that the moon light is actually colder in temperature than the moon shade. And if the moon is supposed to be reflecting sunlight, well, that doesn't really make sense, does it? So that's sort of a thing that you can do on your own to see for yourself that, the moon and the light from the moon is not behaving the way that they tell us that it does.
Okay. I got a question coming. If the Earth the Earth is flat, does that mean there are no other planets behind us? I don't know if that has any any ability to even answer that.
Yeah. See, the whole thing with the flat Earth model and the heliocentric model is like when you start thinking about how the things work on a flat Earth, you really have to, as hard as it is, sort of disregard that whole ball Earth model, because we're not in the flat Earth model. It's like the Earth is a round, it's a round, well, we think it's round plane, right? And then that's like the floor of the universe, like the Earth, like where the ground you're standing on, that's the floor, and everything is up above us, okay? And then all of the luminaries in the sky, instead of being really big and really far away, they're actually small and local and, in our atmosphere. So we have a sun and a moon that are small and about the same size, just as they appear to be. And then you have the wandering stars, which orbit around the sun. They seem to orbit around the sun, not necessarily going behind us. They just get into certain areas where we can't see them. And then you have the stars rotating above us behind that, all rotating around the north. Everything goes around the north, the center, the geographic center of the plane.
Okay. So I think another, to clarify that, with planets and things like that, everything past us looks round. Why are we any different? That's for anybody. I know that's another question that comes up a decent amount. And I like the way you guys explain that.
That's what we call a logical fallacy, right? Because you can't just look up at the sky and assume that what you're seeing is what you're standing on. It's like, if you're on a basketball court and you have a round basketball in your hand, the ball is round, but is the court flat or is it round? If you're playing pool, you have round pool balls, but then the table's flat. Okay, it's like you can't just assume that what you're seeing up there is what you're standing on, because the Earth is the Earth, and then the things in the sky are the things in the sky.
Okay, but that's probably what leads into that belief and that question all the time, is because they're seeing the other, they're playing that, and that comes into play for this. But do you guys know if it comes in, just a off question, do you guys know if it comes into play in any other situations?
Can I say something about that?
Yeah,
real
of
quick?
course. Go ahead.
So, obviously, to determine something, okay, are these two things similar, right? So you look at them or measure them or do some tests and take notice of similar properties, right? So if you look in the sky and you see a planet or star or a galaxy or whatever, then you look at the Earth, to us or to anybody, there's no real similar properties that you can say, yeah, this looks the same, so maybe we're the same thing. It's kind of like a leap of logic. Right, so you just look at something and say, "Hey, I'm going to pick out that arbitrary thing. That's what we're like, and it's round, so we're round." I mean, there's galaxies, nebula, asteroids. I mean, it's kind of like an arbitrary choice that you're picking planets to be like, because there is no similar properties. It could be anything in the sky. You know, if that's gonna be your standard of proof or your rational reasoning, you know, it's like a non sequitur fallacy.
Okay. Yeah. That's what I mean. That makes sense. Just like something like Johnny Flack even said, like, you know, doesn't, or who has said that? It's just Missy said that. Yeah, Johnny Flack makes a valid point. It's a fallacy. You know, I agree. It doesn't mean you have to believe, but that's like one of those points that, you know, you can't always assume just because you see it. That's what it is below. I guess you're right on that one. For sure.
I mean, if we had like more, like some sort of similar properties, we could say that these are definitely the same. But the planets and the stars, they're intangible to us. And I know people probably believe that we went to Mars or Jupiter or whatever. But as far as we can tell from the ground, we can't tell if they're tangible or not. We can't, you know what I mean?
Yeah.
To us, they're intangible objects. And with our abilities, just normal people on Earth, we can't tell exactly what they are. So to make that leap of logic and to say we're the same things, that's not convincing to us. We want to stop believing things. We want like solid proof, you know. And of course, with that comes limitations to the breadth of your knowledge when you don't make assumptions like what can we really know. And that kind of narrows what you can say you actually know, right? If you theorize, you can claim to know lots of things, but what do we really know? That's kind of what we're going for. Figure out what we really, really know.
Yeah. Okay. I'm gonna save this. You know what I want? The seasons. That's another one. They always talk about how do you explain seasons, how do you explain sunrises, sunsets. I think those go decently hand in hand. You know, how is that explained? You know, if the world is flat and not round.
Who wants to take that?
I can, but I feel like I'm hogging all the time.
It's all right.
Okay.
Like I said, it's informal. It's informal. Just jump in whenever you want. You guys don't need to, you know, you could even stop me and be like, wait, I got some more to say on this one.
Which kind of seasons? Because there's actually two types of seasons.
What are the two types of seasons?
There's meteorological seasons and there's astronomical seasons.
And what's the difference between the two?
Can I touch on that real quick?
Yeah,
my
go ahead,
friend
Ron.
lives
Please
in
do.
Tampa. Okay, my friend lives in Tampa, and I live in Detroit. He's about 1,200 miles south of me, and we're both in the Eastern Standard Time Zone. So you would assume that the sun would go down at the same time, right? But on the solstice in Detroit, well, I was actually past the solstice on the 4th of July. I called my friend in Florida, and he's like, well, how come you aren't doing your fireworks? I'm like, what do you mean? The sun hasn't went down yet. He's like, yes, it did. It went down over an hour ago. I'm like, what are you talking about? I said, it's been dark here for over an hour. And, you know, I had already known the earth was flat, but I didn't take it into consideration how much difference there would be in the sunset from Florida to Detroit. And I took a picture. I actually posted it in here. And you could see due west of me, you could see pitch black where the firework is. And then you see a slope from pitch dark.
Which picture was this?
North. The wider the band of light gets. So that accounts for why you have 24-hour daylight in places like Alaska, because the sun is so small and it's circling near the center, which is the North Pole. And that 1,200 mile distance actually made an hour and a half-ish worth of daylight. I gained an hour and a half of daylight near the solstice that he lost, only being 1,200 miles away. That's substantial. So that kind of accounts for the seasons. Same thing. In the wintertime, the sun is further to Antarctica in the flat earth model. It's circling a 60,000 mile lap once per day. So we have shorter hours of daylight in the northern hemisphere, if that makes sense. If you could see the picture, you'd have to scroll up. Just
can you just re-grab that image and post it like to the first one so I can pull it up real quick? I'll pull this up real quick, yeah. I think the government started... Or so eventually they can get very good. Okay. I really thought Broken Gaming was going to be genuine there.
Okay, you can see the firework. It's straight ahead of me. That would be due west, and you see how it tapers. It gets wider and wider the further you head to the right. That would be toward the north, and then the orange is obviously the sun. But if you extended this all the way to Florida, you could see why he's losing time. Picture the sun doing a circle around picture a vinyl record where the center, where the pin goes, is the North Pole. And then the sun is circling around this record. And then Florida being maybe a few inches outside the label. And then Detroit being like right where the label on a 12-inch vinyl record would be. That would be like where the sun is circling. So being that it's so small, and you could see the angle that it comes in at. If the sun was going over the edge of a globe, you'd see a uniform left to right sunset. Across the horizon, you'd see this nice uniform line, like NASA depicts it. You wouldn't see a sloping angle from pitch dark to sunlight.
Okay. And that's why.
Yeah.
Do you think that they know what a record is? I'm just kidding.
A vinyl record.
It's an ancient artifact.
Did they come back into trend though? I thought they came back. I thought those were starting to be things that everybody's.
Yeah, but you can't find a record player, so.
Yeah, true,
I don't
guess.
have a record player, but I've got stacks of vinyl. I got.
Compasses. Are they pointing to the center?
Well,
And east. That's you know what? Not even. I'll get a little more detailed. North, south, east, and west. You know, we think north is obviously moving towards the North Pole. South is moving towards the South Pole. East and west is around the equator. What is that, and why is that wrong?
Right. So the North Pole is still in the center. I mean, it's basically just like a flattened out ball. But instead of south being at the South Pole, the south would be the outer edge, and the north would be the center, and then east is going, one way around the circle, and west is going the opposite way around the circle. But if you, put a compass on with like a magnet in the center, and the compass will always point to the magnet in the center, you can move that compass around, and it still always points north, and you'll still know which way is east and west. Yes, just like that GIF you're showing.
Okay.
Hey, Karen, have you touched on the laser test that you did?
No, not yet in this chat. No.
Yeah, that would be probably be a home run for people that are kind of on the fence. Jose wanted you to mention it.
Is that picture that you posted in the beginning that was going to use for the slide?
It was the FE Core experiment. They did it over a frozen lake in Hungary.
Yeah, the lake wasn't frozen when we did the test, but it was really cold.
Oh, okay. Yeah, it's even better.
Is it the blue and the green laser one?
Yeah, we went to Lake Balaton in Hungary, because it's a really, really large lake over there in Europe, and we had a custom laser built, a high-powered laser with a highly collimated lens built, and then they also, the other guys in the group, they built a mount for the laser. It's called a SALAD, a super accurate laser aiming device. And we shot this laser across the lake, and we were able to see it at 21 kilometers. We did a few different measurements over there. We did 12 and 21 kilometers there. Which and you can see right there in that picture. Well, I don't know. Are you showing it? I better.
Yes. Yeah.
Okay. So they are right next to us. It's dark, but you can't see it. But the lake is right there. Like the laser is barely, not even 2 meters above the surface of the water, right? And so then we went to the other side of the lake, and we could see the source of the light. Which should have been hidden behind the curve by a few meters at that distance. So that right there shows that water is level. It's non-convex. It's at that point, it's pretty much proven that it's not conforming to the shape of a ball. The water's not conforming to the curve. So water is flat, right? Yeah. So 71% of Earth is water. So Yeah.
So. What if you don't mind me asking, what do you guys do that you were doing these experiments in Hungary? Like, do you guys, were you just debunking? Is it like, you know, that's an interesting thing to just do on a whim. Were you guys just out there testing, putting money, you know, I'm just curious into the whole process behind it. Or you guys were just like, you know what, we know how to debunk this, we got this, and you guys just invested into it? Because I'm sure a salad, in your form of salad, it sounds decently expensive. I know it's a little off topic and not really explanatory, but I'm interested in like how you guys got out there.
Well, it's just the group is made from a bunch of people all around the world.
Okay.
So we a lot of them are based in Europe. The engineer who built the device and everything, they're based in Europe. So that's why we did it over there in Hungary. And plus, it was a good place to do it because that lake is so big. You know, it's the perfect place to do something like that. And then we also did it when it was cold because they had done a laser test over this lake 2 years prior in the summertime. And when you have higher humidity and stuff, you get different effects from refraction and stuff like that because of all the water and particulates and stuff in the air. So we did it in the same lake in the middle of winter, which we still got refraction, but it was just a different kind of refraction. The laser was actually bending up, not down. But we were still able to see the source of it.
Okay. That's interesting that you guys were able to do that with those crazy high-powered looking lasers, lightsaber looking things.
Yeah. And they also did a test, a measurement in the Netherlands over Lake Isel over there. And there they did an even longer measurement at over 40 kilometers with the same results.
That's 25 miles for Americans.
Thank you for that. I appreciate that. You're speaking
Sorry.
in. No, I'm just kidding. I know kilometers.
I'm
Don't
so
worry. I
used
know
to
kilometers.
working in kilometers now. It's like, I wish everybody was on the metric system now.
We got to be different. We're Americans.
Yeah, but if we went to metric, nobody would understand the measurements of the Earth being 666. Like,
Yeah.
We were just talking about that, the metric system and in the voice chat. I was pointing out to them that the meter is based on the circumference of the globe to the North Pole, which is why I try to stay away from it, as well as the kilogram. It's kind of tricky. Yeah.
what if we didn't know about miles? This whole thing about the curvature at 10 miles being 66.6 feet, or at 100 miles being 6,666 feet, none of that would make sense. You know, even the orbital speed around the sun, 66,600 miles per hour. Do you think that's a coincidence? I mean, as well as the tilt of the Earth. You take the 23.4 and you add 66.6 and you get a perfect 90. And the Earth it's at a perfect 90. The Polaris is at a perfect 90-degree angle to the water, which is sea level, to the oceans. They're all connected, right? Picture this. We have, they wanted to do a sea level trench through the Panama Canal, but it was too much labor. But it would work perfectly, just like the Suez Canal. There's both of those oceans are the same level. They're not curving around the globe. And also the state of Florida, it only averages about 6 feet above sea level, and it's 160 miles wide, the state. So there should be 3.2 miles of curvature, meaning elevation above the ocean. We have the Atlantic on one side and the Gulf of Mexico on the other. Both of those bodies of water are the same elevation. So where is the missing 3.2 miles? How can the state average only 6 feet above sea level? That means it's dead flat. The state is dead flat, as well as the water.
Lost me in some of those mathematics, but then again, I'm terrible at mathematics.
Let's keep it easy.
Yeah, thank you. Let's bring it down for my sake.
Okay, I'm from Michigan,
Yeah.
and it's basically a peninsula, just like Florida.
Okay.
The mitten, we have Lake Michigan on one side, we have Lake Huron on the other.
Yeah.
And you can Google search, what is the surface elevation? 577 feet for Lake Michigan and 577 feet for Lake Huron. That means they're the same. So across the state of Michigan, it's 240 miles wide, right? So at 240 miles, there should be 38,400 feet of curve between those 2 points. So that's over 7 miles of curve between those 2 points.
Yeah, okay. I got you.
So where is it? The average height above sea level for the whole state is probably around maybe 200 feet above the lakes. Most of it's within 100 feet of the surface of the lakes, most of it. And in Florida, most of the state is only 6 feet above sea level. So where is the missing 3.5 miles of curve? It's over 17,000 feet of curve. There should be over 160 miles, which is the width of Florida. We know the two sides of it are surrounded by ocean, and that's why they call it sea level. The state is very flat, but so the oceans are dead flat. Water never bends. Water never shows convexity, and that's proven by what I said earlier. The two lakes. How could two lakes, Lake Michigan and Lake Huron, be the exact same surface elevation? If you measure diagonally from Chicago all the way to Canada, you're talking over 500 miles. So that means the shoreline around that area is also the same elevation. So it's basically a giant extended flat plain. Just like Lake Baikal in Russia, when that lake freezes, it's about 400 miles long, and it becomes the longest flat surface on Earth. When it freezes, there's zero curvature. We also have salt flats. There's one in Bolivia. I posted a link to a video. There's a salt flat in Bolivia. It's over 4,000 square miles, and it's also 12,000 feet above sea level. And you're like, well, how did this get there? I guess it was like a salt lake that evaporated. Same thing like Bonneville salt flats. And when the water evaporated, it left the salt behind. So I cut out for a minute.
Is it this? I think it's this, like the video, the YouTube video, right? The salt flat.
Yep. That's, yeah, you could see people driving across it. And what it does, it creates a perfect a mirror effect. When it rains, you get a perfect reflection off of the water. But if it was curving, like people say that, oh no, it's curving, it's all relative to the core of the earth, measuring from the surface to the center of the earth, those points, that's what they're talking about. That's how sea level works. I'm like, no, level means level, it means flat. So you would have a distorted image, like a funhouse mirror, like a parabolic mirror, if you had a curvature to the water. But basically, like I said, when the water dried, when it evaporated, it left the salt behind, and it deposited it perfectly flat and level. So if you walk across the salt flat and you place a carpenter's level anywhere, north, south, east, west, you place it anywhere on there, the bubble will be between the lines. It's a perfectly level surface. And the only way that could be possible is if the earth was level, was without curvature, level and flat. And we also have one in Bonneville where they race cars. The reason they race cars there is because it's such a great, it's a perfectly flat surface. So if you get off your track when you're doing a land speed record, you don't have to worry about flipping the car over. If your road had a little bit of tilt to it and you got off of the line a little bit, it would be it could be terrible. So they want a giant flat surface. So if you veer off to the left or right, you're okay. You got lots of land that's dead flat.
Okay. Yeah, the salt flat looks pretty interesting that there's even a place like that, but I see what you're saying. I don't know anything beyond how curvatures would work at long distances and distortion of images, but
like a fun house.
Yeah, I got that.
Standing?
Do you think it from that distance, like is it like just something that because the curve is so long, supposedly, that it would curve at such a small minute, or is it because the angle that you would see it from that distance curving or distorting?
Well, here's the thing: if you have 1 inch deep of water and there was a curve, it would equal a dry spot. That means it's dead flat. The surface of that salt is parallel with the water, right? And if the earth was curving, the salt would be curving. You'd have a parabolic. There's actually a lot of curve. Like over 10 miles, there's 66.6 feet of curve, almost 70 feet. And that salt flat is 100 miles wide. So there'd be a mile and about a mile and a half of curvature in the center. Picture a mile and a half straight up and then sloping down toward the edges, 50 miles each way, a mile and a half. You're not going to notice that? do you think the water would drain off? You know what I mean? Even if the water was curved like that, that's a substantial amount of curve. You would definitely see not only left to right, but front to back. And
I'll say something about the salt flats, about the mirror, right? So here's it. What's more important than the reflection is how the reflection looks when you compare it to the sky. So they're perfectly symmetrical images. So you know the light from the sky, because our eyes don't extend out to see things. Light comes from objects and enters the eye. So when you see an image, if the light is we assume that the light is coming in a straight line. So half of that image is the reflection. The other half of the image is the sky. We know the light from the sky is coming in a straight line. There's no way the reflection can come in a straight line off of a curved surface, right? So the rays will be diverging when they reflect, right? So you'll have a ray, at one location, and a meter away, it's going to be reflecting at a different angle. And then, another meter away from that, it's going to be even more of a different angle. So you'll get a distorted effect. There's no way the sky and the reflection of the sky could look symmetrical.
Okay.
I mean, just think of looking at in a spherical mirror at to Stop Shop.
Yeah, of course.
There's only one location, right?
Yeah.
You have to be in a specific spot to see an undistorted reflection. You have to be looking directly into the center of that. Anywhere on the edges of that, it's going to be distorted.
Yeah. Okay. Keeping in with the line of momentum, what's holding the water in? I know this is a jump around a little bit, but I'm trying to
This is another edge question.
This is an edge question, but this is
pouring over the edge.
Yeah, what is keeping all the water in? Dipping into the ice wall probably a little bit. Trigger words that people hear and you jump right into usually. Like I said, I'm trying to come up with things that I see in chat that aren't overly, just troll, and then also things that I've seen and heard people ask in the Discord and stuff. So, and if you guys if I say something and there's a better way to put it, correct me on it, and then just turn towards something else. You know what I mean? That's fine with me. You don't have to answer it directly. I'm trying to take things that I know people jump all over as soon as they're heard. That's their end all.
We think Antarctica isn't an individual continent, but is more like a boundary, like it was already described. So if you even look at the official records of Antarctica, what mainstream science says, it has an average elevation for the continent of 9,000 feet above sea level, right? Yes. So there's no ice wall per se. It's more like a natural barrier that happens to have really cold, so there's 200-foot glaciers on the shore. Only 5% of Antarctica's actual shoreline that you can walk up to. If you tried to sail up to it, you're gonna hit an iceberg, or you're gonna hit a huge ice shelf. So
there are parts of it that is basically an ice wall. I mean, you could just Google it. Just Google Antarctic ice wall, and you'll see images of it. I mean, the whole thing doesn't look like that, but there are parts of it that does look like that. I'm sorry, go ahead.
No, go ahead. No.
Just keep jumping in, that's great.
Hold
1 second.
There's a reason that we think that Antarctica is surrounding us, and it's because Captain Cook was one of the first people to make an expedition to that area, and he recorded a 60,000-mile journey, supposedly circumnavigating Antarctica. Now that's almost 3 times the diameter of the Earth, or the circumference of the Earth. So either he was the worst sailor in the world, or he discovered something that today we don't recognize, or whatever it is, buried history or part of the deception. So I mean, he's not the only one that measured this incredibly long distance. There was another Antarctic explorer who measured something like 50,000 miles. That's how long they traveled. Was it Magellan? So they recorded 50. Yeah, it was 50,000 miles. So the official numbers are that Antarctica is only like 11,000 miles in circumference, or that continent. So it's like, how are these things possible? You know, it's like history was changed or rewritten, or that part of history was like ignored.
Yeah. And I think I see a lot of questions. I'm purposely skipping questions in chat of like, you know, the more governmental side of things and trying to stick to science right off the bat, but we're getting towards that. Do you guys have anything else that would be like pertinent information towards the science of it that we talked about maybe last time or that we didn't jump into?
Can I talk about the magnetic field thing?
Oh, so, yeah, that's it. The core and all that stuff.
Compasses don't point toward the poles.
Yeah.
So compasses don't point towards poles, right? Compasses align within a magnetic field. They're not pointing toward the poles. It's kind of like a misconception. So we have something called magnetic declination, and compasses align towards wherever the field is. So if you go like to an area of Pacific Ocean, the magnetic field lines actually point east and west. You know, what we think of east and west. So the idea of north and south compass is kind of a little off. And also the coordinates. This is another thing. East is defined as like where the sun rises on the equinox, and west where it sets on the equinox. And those east and west isn't like the east and west that you see like latitude lines on a map. They don't exactly match. That's kind of like a misconception. So you can go on like time and date or SunCalc and punch up the date for the equinox and look at the angle of the sunrise compared to true north. And you'll see that like if you go to like Greenland or anywhere really north or south, the sun actually rises not at 90 degrees from true north, like everywhere on Earth. See, that's one of the kind of things about the gold model that isn't actually correct. They say on the equinox, the sun rises 90 degrees from true north at every location on Earth. But if you look at the actual data that is out there, that's actually not true. It's just like something people believe because that's the way it's supposed to work. But the actual observation data doesn't support that idea.
Okay. The core. That just triggered me to think about the core. Gravity is as a magnetic field.
Core. I don't even want to think of the core.
Yeah. I think that's where you were going because that's what it triggered me. Like
the self-perpetuating magnetic core.
Yes. That pulls everybody, towards it.
That pulls everything towards the center, except for compasses. It pulls towards the top, right?
Yeah, that core.
Yeah, well, the thing with the core is they say that the core is molten iron in the center of the Earth, right? Well, there's something called the Curie temperature, where once any magnetic metal reaches the Curie temperature, which is when it becomes red hot and molten, it can no longer hold a magnetic field. So that really doesn't add up in the ball model.
Doesn't add up in any physics anywhere.
Right? Yeah.
Yeah, so it's like almost 4 times hotter than like the Curie temperature of iron, the core of the Earth supposedly, right? So how can it be magnetic if it's in a state where it can't be magnetized?
Okay, now
what they do is they start this chicken egg problem, right?
Yep.
So they say that, well, it's actually like swishing around, and because the iron is swishing around, that it's creating an electrical current, which creates a magnetic field, which creates electrical current, which creates, and it's infinite elephants all the way down. What came first, the chicken or the egg? So was there a magnetic field and then the current, or was there a current and then a magnetic field? So this is like a thing that they just say, this is how it works, but there's no way to demonstrate it or verify it. And there's no scientific evidence of it. It's just like a plausible story. But it's not even really that plausible.
Yeah. Now they say that it's the pressure that produces the magnetism of the core. I have no idea. I'm
that's
just
the
looking
first
at things.
time I ever heard that one. That's a new one.
The pressure of the core.
I've heard that before. I've heard that somebody says that because it's under pressure, then that's how it's able to be molten and maintain a magnetic field. But show us that. Show us a demonstration of that actually working in the real world. And I haven't seen it yet, so that's just another guess.
Yeah. Okay. What else? You guys have anything else before we jump into the government side of it? Because I see a lot. I'm not purposely skipping questions in chat. I see some of you guys' actual questions that pertain more to like, oh, what do you think is beyond this? What do you think is beyond that? I want to get to what, is more like scientific behind it right now instead of that stuff.
Well, Indio, would you like to cover infrared filters and what's going on with that right now?
I just posted that, Jose, that the video. I was going to touch on that. We're just thinking the exact same. There's a guy on YouTube. I posted his video, and he was flying over Lake Ontario, and he could see Hudson Bay, Canada, from like 1,000 miles. I think it was 1,000 or 1,200 miles. He's not exactly sure, but you can see vast distances with infrared. It seems to cut through all the clouds and stuff. And he also had one coming from like California to Orlando, where he could see mountain ranges 500 miles away, and somewhere around Vegas or something. But this one is more impressive. It's over 1,000 miles.
Okay, I see
Yeah,
that.
the thing about infrared is that it isn't absorbed by water vapor. So it can just penetrate through haze and fog and clouds and all that stuff. So if his observation is correct, because it's hard to see obviously at a distance so far. So he took a camera with an infrared filter, 950 nanometers, and he took a commercial flight, and he was at 33,000 feet, and he probably caught like the edge of Hudson Bay. That's like 1,200 miles. And if you do the math of 8 inches per mile squared, 1,200 miles, Hudson Bay should be like 120 miles beyond the horizon, like around the curve of the earth, under the horizon. So it's these types of observations that are like unexplainable. And this isn't the only one. This is just an example. 500 miles to the Colorado Rockies he took with infrared. I think it was like 500 miles to the Sea of Cortez from Las Vegas. So this guy, he's an engineer. He happens to fly a lot as part of his work. So he's been taking that opportunity to make these observations. And it's coming back that he can see incredibly far distances with this particular filter. Like way further than you should see. It's not even like in the ballpark. Like, you know what I mean? It's not like maybe there's some refraction. 110 miles beyond the curve of the earth is far. Like,
yeah,
it's supposed to be like 110 miles down.
I thought it was 125 at 1,000 miles.
Yeah, it's something like that. Yeah, it's something like that.
Right, and when you could see in his video, you could see it's dead flat. You look at the water, you could just see it looks like a giant slate, like a billiard table.
And the best thing about his observations is he just like casually records out the plane window. You can watch him take the filter, put it on and off, takes an image of like a GPS and altimeter, all those things to tell you his height, his airspeed, all the things, all the conditions that he's filming from. And then you can just watch him put the filter right back on and just zoom in. It's easy to tell it's not doctored, faked. They're continuous shots without edits. So it's pretty good evidence, I think, in my opinion.
The lakes measure flat. Like, you can Google Lake Michigan surface elevation, Lake Huron surface elevation. They're both the same. There's zero curvature. They're equal. There's no change. They're even. Just like the word horizon, I put in there a link of synonymous words. Horizon means horizontal, level, even, flat. All the synonymous words with horizon. Then you look at other things like salt flat. What is flat? Is there any wiggle room with flat? I don't know. What about sea level? There's no wiggle room with level. It is what it is. It's flat, plain, level.
Okay. That's an interesting video. It's just to see it in infrared as well. Oh. Then he takes it off and blinds everybody. All right.
Yeah, and there's like a modification, because you have to actually like modify your camera to do it, because cameras have like a mask, or like an infrared mask. So you actually have to go in the camera and like peel this thing off. so that the infrared actually passes to the sensor.
Yeah.
Then go buy a filter. So 950 nanometers isn't even like optimal filter. That would be something like 1200 nanometers, but they're like, you know, probably owned by the military and they're super expensive.
I've used some decent infrared things. I've used them with all these different optics, but that looked crazy. I don't think I've used an infrared camera itself.
Hey, Indio, could you cover the angular resolution? Like, explain why things go to your vanishing point, how that works?
Yeah, so
the vanishing point. Are you talking like that's the classic ship goes across, like away from the horizon, kind of over the horizon?
Yeah, the ship's over the horizon.
Okay. The ship over the horizon.
This one makes me laugh. I'm sorry, because it's just like I don't know. Okay, so
it's funny because everybody's in here when we're talking about the water measuring flat. Oh, well, 40 kilometers. Well, that's not far enough. You know, you're going to sit here and tell me that's not far enough. But then at the same time, you know, what? So we can't see the curvature when we're on the surface of the Earth. But at the same time, you guys think you're going to see a ship going behind the curve? You can't have it both ways. You can either see it or you can't, right?
Isn't that the human eye? The vanishing point is between 3 and 6 miles. Lake Michigan is 60 miles long, and there's pictures of the entire Chicago skyline from 60 miles away. You see the buildings that are like 100 feet tall, and the curvature at 60 miles is 2,400 feet. Is that far enough? If 60 miles is not far enough, what about 600 miles? I mean, what's enough to show that there's no curve? Even those two lakes, Lake Huron and Lake Michigan, that's over 600 miles from Chicago to Canada, the shoreline. If you measure diagonally from, you know, as a plane would fly, and it's all the same elevation. There's no change. It's flat.
So I'll explain the boats over horizon. It's going to be kind of like a thought experiment / example, right? So imagine you have a 6-foot eye height and somebody sticks you into a 6-foot hole so that your eye is parallel with the surface of the ground. And the surface of the ground is an infinite plane extending forever. Now, it's impossible to see the surface with a 6-foot eye height from being inside of a 6-foot hole. It's impossible. But if you raise up a little bit, you will start to see more and more of the ground. Now, say you raise up 1 centimeter. You think you're going to see the surface of the infinite plane? Are you going to see something 10 miles away? Are you going to see the bottom of it? No, because your angle to the ground, to that surface, is so shallow, it is beyond the angular resolution of your eye. But as you raise up, as you get higher, to the horizon, your apparent horizon, will extend as you get a better viewing angle to that plane. Is that understandable?
Yeah. So this
it is a shallow angle of view. So when you're looking at something very far away, you get a very shallow angle of view to the point where it's beyond the angle is so sharp that your eye can't resolve it.
Okay.
So
I'm looking at this
apparent horizon, basically, and anything beyond that apparent horizon looks like it's obstructed, like obscured by things. It doesn't even matter whether it's a plane or a globe. It's just a fact of vision that this would happen. It would happen on a globe. It would happen on a flat surface. It would happen on any shape.
We can explain it like this. You know how the sun and the moon, right? If you look at the sun and the moon and you hold your fingertip at arm's length, you could cover up the entire sun or the entire moon. We know your thumb is not bigger than the entire moon or the sun, right? It's all your perspective. So what he's saying, like the angular resolution, the further you get it away, it's going to be looking like 1 pixel.
Yeah.
You know, as the sun is vanishing, say you're at the equator, you see the sun just getting smaller and smaller and smaller. So it looks like 1 dot, and then that dot just disappears. It just fades away. So if you had like a monitor, it would look like 1 little pixel, and then it just gets too small for your eye to see. You know, it's like the size of a tick, or even smaller, like microscopic. It just vanishes.
Yeah, because scale and stuff. At that
yeah,
distance.
Rod's talking about linear perspective. So objects, you double the distance, it halves an angular size. So if it's one size at 100 feet, it's going to be half that size at 200, and it will half again at 400. that's called a linear perspective. So it's a combination of these two effects. This object is shrinking smaller and smaller. But in our vision, things, the ground, we know it's below our feet, but it appears to rise up to eye level. So this thing's shrinking, the ground is rising up, and eventually they meet at some point. And this apparent horizon created by the shadow angle, the object is still shrinking, and it appears to just sink into the horizon, into the vanishing point, until it disappears. Now, if it was a globe, you would see this effect and the curve of the Earth. So not only would it be shrinking and the ground rising up, it would be going over a curve, disappearing faster and faster exponentially. We don't see that. When we see this ships over the horizon phenomenon, they slowly fade away, right? They slowly, over time, with distance, disappear. What we should see on a globe would be it start to disappear and then vanish almost instantly.
And then no magnification, no amount of magnification would bring it back, because essentially it went around the corner. If it goes over the curve of the Earth, that would be like if you're in a city and you walk around the corner of a building, I can't pull out my telescope and make you reappear. You're around the corner. So that argument goes out the window. Well, you use the telescope, yeah, and
Okay.
Yeah, and Karen brought up a big point. The conundrum of the Earth is too big to see the curve,
example, but
we can see the curve at 3 miles on a ship. I mean,
we're gonna see that in a second.
it can't
Bucky,
be both
we're gonna talk
ways.
about
It
that in a
has to
second.
be one or the other.
It's in Alaska. Okay.
and we could see Chicago from 60 miles. If 3 miles is where ships disappear, what about 60? That's unthinkable.
Yeah.
That's from like ground.
And this is all stuff like, because obviously talking about it, people are gonna be like, yeah, okay, like unfathomable distances, things like that. These are all easily searchable via like YouTube and things like that.
Mm-hmm. Yeah,
Well-
you can search up Earth curve calculator,
Yeah.
and there's a GitHub Earth curve calculator. I mean, because the Earth, they do give us a finite size for the ball Earth, and just by the very nature of the shape of a ball, and if everybody is technically or theoretically on top of the ball, you're always on top of the ball, right? So from your point of view, just how a ball works, at some point things need to start going around the curve of the ball, and they need to start disappearing out of the view. So there is a finite size of the Earth. There is a mathematical equation that gives you how much distance and how much you should see at that distance. So these are things that you can go test for yourself. Just need to go somewhere where you can see far enough.
Okay.
And just to give you a little heads up on the curve calculator she's talking about, I haven't seen one that accounts for angular resolution, as in like objects reducing in size. Because we all know when you use a curve calculator, it works like with an orthographic view, meaning it deals with absolute sizes. So like if a mountain is, let's say, 1,000 meters high, on the calculator, it assumes it's 1,000 meters high regardless of the distance. But we know that things with distance shrink in size. So there's no curve calculators that account for this reduction of size, which can also explain why things look lower in height because they're reducing in size. It could also explain why things are being obstructed. India just kind of gave you a little example of the boats. It applies to the sun. It applies to why the sun sets. It applies to like boats. It all coincides with things disappearing bottom up. It's the same thing. Just wanted to chime in on that real quick.
Yeah. Like we see in angular sizes. We don't see in absolute sizes, right? So
Yeah.
we can't see something like, that, say, a 10-foot wall a mile away. You wouldn't measure that wall that way, right? You couldn't tell it's 10 feet tall. You would actually have to go physically up to it and measure it with something like a tape measure. So a lot of these calculators are what Jose said, orthographic view. So they deal in orthographic sizes, but it doesn't accurately represent how we see things and how we visualize things.
Okay. Yeah, I see what you
I mean, we
mean.
can
Like,
get an
obviously,
idea,
at distances,
But you
things are
actually have
smaller.
to work out the angles of how much of an object is visible.
Yeah.
Just going by absolute heights and sizes, that isn't really going to give you the information you need.
Yeah. Well, I mean, that's why, like, say, take scopes, for example, like an ACOG scope. It has smaller lines going down, segmented for distance, and that's, they're smaller as they go, but that's still the width of human shoulders. You know what I mean? 'Cause
what's
they're further out,
interesting?
obviously.
The vanishing point of your horizon, it's always even with your eye. it's always a level plane with your eyeball. So if you stand or you sit down, it moves. It stays right where your eye is. So if you go up 120,000 feet, it's still
ice wall,
level
Granty.
with your eye. And someone did a calculation. He was in an airplane, and from his angle, the horizon should have dropped about 4 degrees. He did all the calculations. I'll drop the video right here. He did it all scientifically. And according to this, if we're on a globe, the horizon should drop down. It shouldn't just remain level with your eyeball.
Okay. Yeah, I know what you mean, because that's exactly why, like, from distances, like I said, I took in the scope example because that's what I can relate to specifically. You know?
That is a perfect example.
The size of you wouldn't tell if I look.
Yeah, they got it on the Dragonov scope too.
Yeah, well, yeah, in any ACOG scope, any ACOG scope, that's how they use it. They use the vertical lines, those tick marks down below. They get smaller, not for anything, but that's the shoulder length of the average male from that distance specifically. So if 600 obviously is like half the size of 100. That's what you're meaning by the visual, the way we kind of perceive things from distances.
Yeah, that's how we see things. We see things in angles, not really like absolute sizes. Absolute sizes are for like building things. You know what I mean? It's a totally different application. You know, if you want to build a house, that's fine, but no one's going to build a house from a mile away and say, you know, that wall's 20 feet and, you know, that's 15 feet. You know what I mean? That's crazy.
True. All right, so I'm going to ask some what ifs right off the bat, unless you guys have something real quick that you want to jump into with that. But
I have something I want
go right
to
ahead.
add. Remember, you were talking about rifle scopes, right?
Yep.
So if you were sighting in your scope and you're off just 1 degree, at 100 yards, you're going to miss your target by 5.2 feet. Just being off 1 degree, right? So at a mile, you're going to
depending
miss
on the
by
ballistics,
90.
the velocity of the round.
Well, it's always 1 degree. Like the 1 degree is picture a straight laser beam line. That's how much it's going to be off the bullseye.
Okay.
You're going to miss by a lot. So all this stuff factors in when you're talking about being able to track a planet that's you know, millions of miles away with a camera. That comes into effect. You would have to have like perfect alignment, and keep in mind the Earth is spinning and that star is also moving. So you have this really narrow field of view, as if you could focus in on something that many millions of miles away with a telescope or a handheld camera. That's what tells me it's all BS. Because with my I have a Nikon P900. I could zoom in on Mars. I could keep it right in the center of my reticle, and right inside, you know, right in the center of the focus. And that would be impossible if we were spinning, you know, like what we're explaining the rifle scope, how accurately you have to have it aligned, you know, and it's moving and you're moving, you know, that would never be possible. You could never align it perfectly with your camera or your telescope.
Okay. All right, well, I'm going to jump into the what ifs that keep getting spammed in chat and all over the place. These are the more, not what ifs, but like why, or, you know, like, for example,
the why lie.
Why lie? Why lie? Why would they pull the shades over our head about, you know, the Earth being round? Why is there somebody out there keeping us from, you know, going past a certain point south? Why?
I think you'll find that everybody has their own opinion on that. I mean, it's kind of like the ultimate question, right?
Yeah, that's the one that's probably the most.
This is like, it's like you find a body. We also often think of it as like a murder, right? So it's a crime scene. We got a smoking gun on the floor. There's a hole in the dude's head. He's dead. There's nobody around. And, but you know you have a crime. You know there's a murder. But you don't know the motive, right? So
what are the most popular ones out there? I know that this is way too like ridiculous. Like you can't, obviously if you knew why, then it'd probably be a lot more easy to portray to the mass.
My personal one is something I read in a book about when they decided there was like a contest to measure the equator, and basically they said was to save their reputations, because they had come up with this globe model. They hooked like map making to the stars and astronomy. And basically, if they were wrong, that they were gonna, like, you know, go down in infamy as being buffoons. And they went and did this basically to save their reputation, even though, you know, that might be part of it. But that's just my personal opinion. Other people think.
Okay, so you think they're saving face from all that time, and then we'd have, they'd have to debunk everything, and then like people. Are you saying like it drive a little bit into a chaos?
More like the people's personal reputations. Like, think about it. Like, all these people that were regarded as geniuses and famous, and they came up with this Copernican revolution model of the world. Imagine after 200 years that they were wrong. And all the people that supported it, and the whole society that built up around it, and the ways of life, and all these super smart people and universities, and all of a sudden, boom, that whole globe idea. Nah, man, that was wrong. The Earth's actually flat. I mean, they would have hung those people.
It's true.
Yeah.
Hey, real quick, Zunit, I'll answer for you in a different way, just for your audience.
Yeah, I appreciate it.
I want to hear a little bit more.
Yeah, I want to hear more. Exactly.
Right. So, for your audience, I'm not saying I believe this because I'm not 100% sure of this, but it's an idea. There's a Navy admiral, which his name is Admiral Richard E. Byrd. He's I believe he was an admiral in the late 1940s, 1950s, early 1960s, maybe. This guy, what he did was he was our Indiana Jones, our best explorer for the Navy. He did a couple expeditions to Antarctica. He did Operation High Jump, Operation Deep Freeze, and Operation Fishbowl. And what he did in these explorations was obviously explore Antarctica. Obviously, the names are kind of encoded if you think about it. Operation High Jump. I mean, flat earthers already think there's like a wall of ice or, something like that. So it just kind of goes with the names too. Like you got an Operation High Jump. That sounds like they went over this wall, right? And then you got Operation Deep Freeze. That sounds like they're already inland. And then you got Operation Fishbowl, which correlates to some flat earthers will say that has to do with the dome, where they found the perimeter. But not just that, this guy actually came out on live television on this show from I forget what year it was, but it was called the Longines Chronoscope. And he gave this speech they asked him, hey, is there anything new to discover? And he said, strangely enough, there's a place the size of the United States on the other side of the South Pole from Middle America. And it is astonishing, a continent this size that hasn't been discovered. He claimed that there was uranium, enough coal to fuel the earth for years, just a lot of resources. And guess what happened after this speech? A couple years later, Antarctic Treaty is formed, the UN is formed, and we start space exploration with NASA. So there's for anyone that wants to hear the conspiratorial story side of it. I'm not saying that this is 100% fact and I believe everything he's saying, but it gives an idea of there's possibly more land that they're hiding, resources, etc.
Yeah, I have a simpler answer, but it has to do with because when you ask why lie, it is assuming that government or these people who are in authority never lie. So the question is, have they ever lied to us, right? I mean, I posted a link to the Royal Society, and so you have to be a fellow of the Royal Society. And what is the Royal Society? And you start going back, and then you'll start running into these esoteric, like these people were religious. They were like, science is the study of physical reality so we can understand how it works. And that traces back to religion, back to a creator, back to God, if you want to call it that. This thing that we've been given called the globe is not the real knowledge that they know. So we're given some kind of arbitrary systems so that we can do the work that is required of us, but not the thinking. So, I mean, just looking into this Royal Society, you'll see they say science, they use the word science, but what does that word mean anyway? You know what I mean? So there's a lot of deception going on when you ask that question, why would they lie? And the simple answer is, why would anybody with knowledge lie? And the answer is for power and control. And everywhere you go, this is how knowledge is handed out. You have to keep coming to me for a certain amount of years, and then you can earn this degree that says you are knowledgeable in this area of science, in this body of science. But in order for you to get this degree, you have to learn this and learn that. You have to, like evolution and the globe. and only then are you considered a learned a person who has the authority to speak on science. It comes from these people. All this regurgitating that people are doing comes from school, and that knowledge comes from these people. I mean, it gets even
Yeah.
deeper, yeah, and even, it gets way deeper than like this thing we call quantum physics and quantum mechanics. What CERN is doing, these there's a Kali, there's a statue of Kali there. We see all these symbolic rituals and the things that they're doing. They're calling it science. They can't explain it in layman's terms, right? But they're still developing these theories in secret. Yeah, but look at the Royal Society, and you can determine if these people are actually scientists like we think they are, or something else. Just wanted to add that in.
Okay. Yeah, I think that's one of the that's probably the most interesting portion for me is like why would that be, a thing. Like, we can dig deep into why they lied about going into space, or why, whether or not they did, or whether or not you guys believe they did, why they would take pictures and manipulate fisheye lenses, why they are holding onto potentially something out past the wall that's pertains to power, money, whatever, greed.
Yeah.
But at the end of the day, that's not the non-science portions of all of that. So those are always going to be the, well, this is what we think, this is what it is kind of scenarios until, there is a motive that's identified.
Yeah, there's always a motive. Like, before we were able to sail the oceans, right? We used land to transport, to move, to trade things, right? And if there's a trade route, if there's a road where a lot of traders are moving through, we want to control this route. You know what I mean? We want to protect this route, if you want to call it that, protection. You know what I mean? And then we discover how to sail the ocean and explore. Well, we want to control those routes as well. We want to control everything that moves on the ocean. So that's been controlled, right? And then when the airplane came out, people are now going to have the freedom to explore the sky, right? No, we want to control that too, so we're going to lock it down. And then a little later after that, there's a space program. We've never had the opportunity to explore the skies the way we did the land and the oceans. And even if we did explore the oceans, that knowledge was kept, was protected. We don't want people to. This is how power works. Like, knowledge is the power. Like, if I tell you the truth, then I lose my power. You know what I mean? If I give you all the information, you won't come back to me for anything. So yeah, knowledge. By controlling knowledge, you control the world. You control people, and this is true. I mean, we all understand that, right? Like mom and dad. We rely on them for information to give us. So they control us but they love us, right? So when we look at these people that teach us these things, they are controlling us, but are they looking after our best interests? You know what I mean?
Yeah. Okay.
Zunit, do I have time to speak about one thing that's central to the space, like space travel and all that?
Yeah, go ahead.
There's one topic I'd like to cover, which is
I was going to say
model.
We jump onto the last whatever topics you want to go on about before we throw out the challenge for
all right. So here's
the debate.
And I want to put a comment on this other than me if they want to chime in. But essentially, they need to prove that the medium, which is the vacuum of space, exists, because in a globe Earth model, you have a high pressure system, which is the Earth, adjacent to a low pressure system without a container. We all know that it's impossible to replicate any type of picture like a vacuum chamber, or better yet, picture a tire, how you pump up, you pump up air into a tire. How do you hold the tire pressure without a container, without the tire itself? You need that container, right, to contain the pressure. Essentially, the globe Earth model has pressure, but what's the container for it? A lot of people will say, oh, gravity holds the atmosphere down, etc. But not even the gravity can explain that, because the gas exceeds the escape velocity of gravity. It's a second law of thermodynamics, and it's entropy. So that's something that people need to start to look into, that law, and see how it correlates with the globe Earth, because essentially the globe Earth is an open system.
Mm-hmm.
Okay. Yeah, so, I mean, as we pull up, if anybody else has any more points they want to pull out before we, go into the next, I think which was going to be more fast-paced, and, this is definitely a good, recap on the first one especially. I could probably pull up the VOD and have take both of these VODs and throw them up, post them somewhere so people can review both if they would like to, but, So if anything else you guys want to touch on that you're thinking about the whole time, that would be good information that would stick out. Go right ahead.
I posted a video, Zero Density. It's a company that does CGI. It's to explain what's going on the ISS, how they fake things.
Okay, so this explains. Do you want me to post in chat instead? Post a link? I can do that.
Yep. It's in the Z Unit live chat. Scroll up one.
Yeah, I got it. Okay. You had some, Karen?
I just was saying that I see people asking about how does day and night work on the flat Earth. Do you guys want to go over that?
Is that what I had? That little that crude the GIF with the light. Hold on, let me put it up.
Yeah, with the little light pin with the little glass. Glass dome over the map. Yeah. That does mimic how it works, but one of the things it's when you have to go back to when you're thinking about how everything works on a flat Earth, it's the sun in the flat Earth model is small and close. Okay, it's a local light. It's not this big massive fireball in space millions of miles away. Okay, it's small and it's local and it's inside the atmosphere. Now, also, the other thing is in our atmosphere, we have a lot of gases and actually tons of water. Water is the third most prevalent thing in our atmosphere. And what I like to compare it to is when you watch a submarine or a small submersible go into the ocean, and then the ocean has these different layers, right? The first layer, the first 200 feet is the daylight layer, and then you get into the twilight layer, and then you go a little bit deeper, and eventually you end up in what's called the midnight zone, where the sun can't penetrate through the water down to the bottom of the ocean. It can only go so far, right? So even if the sun is high noon right overhead, you go down in that water deep enough, and you're going to be in the pitch black. So the same thing is happening when the sun is getting far away from our view over the flat Earth. It's just happening at a much larger scale. So it gets to a point where the throw of the light can't penetrate the atmosphere anymore, and then it becomes dark. That combined with perspective and, the limit of our vision, that's how the sun sets on a flat Earth.
Okay, yeah, I see what you mean with this. Now, is this a sphere filled with water?
No, that's just a glass.
Just a glass dome over top of that?
Mm-hmm.
Okay. That's interesting. Yeah. So, I mean, unless you guys have one or two more things, I want to, just say that this was, a good, solid, like I said, segue from the last one, a kind of retouch on the first one. I thought, both of these, were great. I mean, a lot of people give off the, when they think first off flat Earth, they just resort to the memes of the plate and all that stuff. And I think, whether or not you believe or or whatever it is in this situation, in, this ideology or any, it is good to see other people and what they have to offer in a meaningful way, not just, fuck you, you're wrong, for lack of better terms. So I want to do a debate moving forward. We have a few guys involved. I still have a few that I have in mind. It's one of those scenarios we try to do this first, but some of the people flaked out a little bit from our side, to be fair. So I do want to get a couple people, not people that are just going to come in and trash talk and that stuff. So I'm going to pull some people, and we're going to get this going, because I know a lot of you guys. I've had people DMing me, people say it in chat, get me in there, get me in there, get me in there. And all right, I'll get you in there, but just know when I get you in here, you're not going to have a floor to just talk tons of trash. No, I see this a lot. No, I don't believe in flat Earth. But I'm also not against different other people's ideologies and things like that. So
yeah, I wanted to say something about cognitive dissonance, about how people would get they get angry because they feel that their intelligence has been insulted, when they feel like, they're grasping for these people. Like, when you try to understand it, you're going to ask questions like, what about Einstein? What about Newton? What about all these people in the past in history that have developed all these theories, all these laws? They've discovered all these things. Like that is like cognitive dissonance that will just keep your mind closed to what you're looking at. That it requires a little bit of courage to step away and say, and it's not just courage, because I asked the question, what about all these people? And I even went back so far as Pythagoras, and I said, I could not dare question Pythagoras. I mean, he is the king. Why would I dare? But then I did, and it was scary for me, because there's the feeling of being alone now. Like, who? Well, then that means I have to figure everything out by myself. This is a trap that you will be led into, and this has been designed psychologically for you to think this way. That when you think about all these people, there's no way that you're going to be able to figure this out on your own. So you're just going to keep holding on to that cognitive dissonance, and then maybe later on down the line, when you've learned a little bit more and you've kind of figured out some things, you'll be able to say, hey, I don't really need this system that Pythagoras developed for us, because he had to learn from the Egyptians. He had to learn from the Chinese and the Indian and all these other cultures around him. And before he was able to come out, it's called a cult. And there was a cult back in the day called Pythagoras' cult. Even he thought was involved in developing the heliocentric model. Like, it's really strong, and it's really hard to pry yourself away from these people. You know what I mean? So I just wanted to warn and let people know that when you're experiencing that, you might be doing it because you might be triggered because you're holding on to these people and you don't even know who they are or what they discovered or how they discovered it. You just remember something from school. That's all I wanted to
Okay, awesome. Yeah, so I mean, coming up on the time side, set an hour, then we're a little over, not a big deal. What I want to do now, first of all, thank you guys for coming in here. I'm gonna keep in contact with you. We'll stay in this group and we'll chat out and plan out next step for round one of the integrate. So what I might do now is jump out of this chat. Like I said, I appreciate you guys coming in here. I'll post you guys' Discord, so that's where you guys are most of the time, right? You guys have a 24-hour live stream going on YouTube, and then you are in that Discord, and the live stream is for that YouTube conversation, correct?
Yes.
Yep.
Okay.
Got it.
So yeah,
I also have a YouTube channel, Karen B.
Yeah, post them. You can post them right now in the chat, and I'll replay them back. What I'm gonna do is I'm actually gonna get into my Discord. You guys can stick around and listen, and I'm gonna get people's opinions and things like that to give you kind of like let them say their piece on some side. I'm gonna pull selected people. So if you guys want to go to public 2 in my Discord, I'll bring people in or whatever it is. Go to public 2 in the Discord, and I'll pull people into the live admin room who I see fit. I know I'm not gonna pull everybody and not open it up because I know exactly what's gonna happen if I do that. So, but yeah, post that there. I'll spam the link. If you guys want to go debate against these guys on a day-to-day, like I said, join this Discord, and you can.
Yeah, I just wanted to recommend a zunit for your intro.
Yeah, I'll drop that. I'll do a remake of some of the G Unit features for back in the day.
Yeah. That'll get you more views.
Yeah, hopefully. Maybe I'll get a contract with 50 Cent himself. I don't know. That might happen. But again, I appreciate it, guys, and I'll be in touch in a bit to set something up. I did have a lot of messages of people like, put me in, coach. So you guys should have a fun time coming forward. I think that's kind of where the logical next step would be is, put people up in debates and stuff like that. As long as we can maintain, a semi-civil. I mean, people get a little loud, people get a little passionate about it. That's fine, as long as we keep the personal text down.
People do get really passionate about it because it's a very polarizing subject. I mean, we were all programmed to think that if you think the Earth is flat, you're ancient, you're stupid, you're stuck in the Middle Ages or whatever. And you know, we're not trying to convince everybody. We just want people to ask questions. And thank you for having us. I think it's really great that you're able to talk to us about it, even though you don't believe in it. That's a sign of intelligence to entertain an idea without accepting it. So
I think I'm more in, I really am. That's what I think at the end. I'm not saying that's really great high intelligence. I'm saying I have, high interest in this kind of things. I don't, one thing it has shown me is I don't know enough about our globe or our world or what I believe to actually debate it. So if I ever wanted to, I need to step my game up. So in terms of looking things up, at least, you know what I mean? Like, I need to get deep in there because, before that, it's like, yeah, the earth is round. I know this. Why? I don't know. I'll just fucking look it up.
I thought I knew it too.
Yeah. So, all right.
Zunit, something I'd like to emphasize before this moves any further or ends. Again, we're not the Flat Earth Society. We don't believe that we do not believe we're a space disc floating in the middle of space with the heliocentric model. It's completely different. So if anyone is interested into looking into Flat Earth, please stay away from the Flat Earth Society. That's obviously a controlled opposition. It mixes a lot of truths with a lot of disinformation. And it's really discredits the whole movement. That's why a lot of people come on here and be like, oh, so you guys don't think Australia doesn't exist? Oh, you guys think the Earth is rising up at 9.8 meters per second squared? That's not us. That's the Flat Earth Society. It's a controlled opposition. Just need to emphasize that because you have no idea how many people come into our Discord asking us if Australia doesn't exist or if the Earth is accelerating up, and it's just a mess,
Yeah. I feel you.
Yeah, another thing. Yeah, Vsauce is on that. He's on that Flat Earth Society model. He made a whole episode out of it. I don't know why we're over here, not over there.
You mean he's a Flat Earth Society streamer? Or a YouTuber?
Well, no.
Typically what YouTubers do is they debunk the Flat Earth Society's ridiculousness.
Oh, okay.
Basically, so it's like a straw man. It's like the straw man built up that no, real Flat Earthers believe. I say it this way. There's no Flat Earthers in the Flat Earth Society. And that's true. They're all globe Earthers doing a parody of Flat Earth. That's it.
Oh, okay.
And that's kind of what YouTubers debunk, this flawed model or whatever you want to call it that they put out. That's usually typically what is debunked on YouTube.
I am.
And people believe that's what we believe when that's actually not true at all.
Yeah, so much so that Vsauce dedicated a whole episode to it. I used to watch Vsauce.
Like an hour-long episode.
This guy's... Yeah, he spent a whole full episode on it. So you got Barack Obama saying we don't have time for the Flat Earth meeting with Flat Earth Society, and then you've got Vsauce addressing the Flat Earth Society. But we're here. That's what we're saying. We're not that. Why are they? You know what I mean? Like, this is suspicious.
Yeah. So yeah, drop me some links to some of these things in the into the Discord, and we can take a look at them and stuff. So, like I said, guys,
like Alex Jones is like controlled opposition.
Alex Jones.
The Flat Earth Society is like Alex Jones. It's a controlled opposition, and they thought of everything. The globe Earth people thought of everything, all the deception. But the funny thing is, they're very arrogant, and they put their logos everywhere. Like the United Nations logo is a flat Earth map. They like to put it in our face, kind of like rubbing our face in dog crap to mock us. Like, here, we'll put it right in your face, and you're too stupid to get it. Just like all the measurements of the Earth being 666. They do that to make fun of us. They get off on that.
Okay. Yeah, I feel you on that. So that's good. Like I said, that's a perfect thing to say. Like, yeah, the Flat Earth Society, when you look into Flat Earth Society, is not the same as Flat Earthers and the guys in the Discord doing their thing. So, like I said, get into that Discord. If you really want to, you can't wait for or want to be on a live debate and you want to get in there and try to state your case, go right ahead. They have people coming in there all the time doing that. Like I said, it's pretty much 24/7 running. So you can jump in there now, later, tomorrow. Just join the Discord and you guys can jump in there with that. So, again, I appreciate it, guys. I'll be talking to you guys again, and thanks for coming on here today.
Hey, you're welcome.
Thank you for having us.
No problem. Anytime. All right, guys. I'll catch you. See ya. All right, gents. So that was the Flat Earthers side of things. Like I said, I do not believe in the flat Earth, but I also respect other people's intellect into their ideologies, anything like that. And I'm interested. That's what interests me the most. What interests me the most is what other people are thinking, why they're thinking it. Especially in these cases of extreme minority groups, which, by the way, the Flat Earth Society, the Flat Earth group is growing pretty rapidly. There's more media out there. It is one of those things that it's not going down, it's going up. And take it for what it is. But yeah, be sure to follow the freaking stream. What the hell? I had so many people jumping in and out, dude. I didn't want to, stop the debate and be like, what's wrong with you guys? I see a lot of you guys coming in and not following. Jesus Christ. Coming at me all ridiculous. This is zero stream, goddamn. All right, I'm going to jump into Discord real quick and talk to some guys that, I pulled into in my Discord into a channel, and we'll chit-chat for a second about what they think. A couple people got Banjo Briggs, Crixus, Exolorus, and Warhawk. So we're going to jump into there with them. We're going to get some opinions. You guys ask questions. You guys talk however you want, but we're going to see what these guys think. I'm interested in all of these. I know these guys, so we will, go in there and see what's happening. And I see Lymph, you're doing a great job shit talking as always. You freaking goober.
Ridiculous. I can't.
Hello?
Hi.
Don't
Hey,
worry.
guys.
We ran out of tinfoil. We're gonna have to run a store run real quick for you.
For me?
We're making tinfoil boats.
Listen. I enjoy the entirety of all things like this, man. I'm a huge fan of different ideologies and things like that. So I want to get your guys' thoughts real quick. Before we, I know some of you, Warhawk and Crixus and stuff, they want to be in on the debate last time, and this time we're gonna put through on it, and I'm thinking we're gonna put through soon. So just know that. So what do you guys think?
My only question is their daytime and nighttime theory about the 30 days of night versus 30 days of sunlight. Their explanation was the sun rotates just further out, causing the night cycle and the day cycles. Now, if that was the case, the sun being rotated so far out, that would cause issues to more areas than just that portion, causing daylight in that area farther out, and then concluding in further and further to where it'd be night. It wouldn't just be in this area, that area, this area. It'd be gradually out. It'd be night, and then start getting day.
As a resident spaceman, even if the sun was 3 or 4 times the distance away from the Earth as it is now, you're still gonna see the sun. You're still gonna see the sun, and you're still gonna experience daylight. Okay. There's sections of the Earth that legitimately does not see the sun for days on end, and with their disk theory, there's no possible scientific answer to prove that. You know what I'm saying? The sun is a very fucking bright object. You can send that fucker thousands and thousands of, miles away from where it's sitting now, and you're still gonna fucking get a little bit of sunlight. Okay? It's never gonna go completely dark in their scenario. Okay, so explain Norway or the northern parts of whatever country that experiences darkness on days on end. It just doesn't make sense. And I'm triggered.
It doesn't make sense, and I'm triggered.
Listen, at the end of the day, America won 2 world wars. That's all we gotta know.
I knew, to be fair, I knew EXO was gonna be.
That shit in chat.
I knew you're gonna be in here. I knew you're gonna say that. Warhawk, what'd you think, man?
Half an hour ago.
What did I think?
Yeah, what'd you think?
I mean, there's so many different things to touch on, but let's start with
You remember our admin chats back in the day, Warhawk and Zunit? This is what it's about to turn into.
This is not
Warhawk's about to fucking
keep it simple.
I'll be back.
But yeah, I would say the 2 biggest things that are so absurd about this is it's so easy for somebody, I don't want to say these people, but that's essentially what I'm saying here, to believe what they read on the internet. However, I mean, if you look at the laws that exist in the international laws, not United States laws, not any other laws, there's nothing stopping you from going and taking a boat and going way down south to the end of the globe and seeing how far you can get. There's nothing stopping you from going up north and seeing how far you get, or how far west, or how far east. There's nothing stopping you from doing that. So like, where's the pictures of this massive fictitious ice wall that supposedly some people think exists?
And there's plenty of documentation. If you look hard enough, there's plenty of people who have, recordings, a fucking front camera view of them flying around the fucking world, even north to south, circumnavigating the globe.
Their counterpoint to that is that even in a plane or on a boat, I mean, you're essentially just doing circles because, you can't keep a straight line, so you're doing circles on a flight. Which, again, that's absurd, but I'm not going to get into that. The other ridiculous thing that it's more so just the premise of flat Earth theory.
I know I have some counters to many of the flat Earth opinion, but not sure how well I can defend them.
Excuses to justify other excuses.
Start attack my counter.
Questions. And I think that, man, I don't know. I'll leave it at that.
Now, you guys, before, what's up, Banjo? What's up, Banjo?
No, you go ahead.
I was gonna say, Warhawk and Crix. I know you guys were down for the first one. Do you be down for the other one, for the next one?
I would just need a couple of days.
It would be so. What I would do is I would set it up like a legitimate debate. Like I would have questions. You guys would have timed answers, and then kind of like a back and forth a little bit. To an extent. No, it wouldn't be just.
Open floor.
Yeah.
It would be. It would be open floor to where you guys can if you guys are, both sides are doing well with the open floor and not going too ham. Then I would be, cool with letting most of it just play out and just driving it through questions for time's sake. That's kind of how I would do it. And then I would prep the questions, throw both the questions at both sides beforehand so they could both have something for them, and then you guys will have ample time before that. Maybe I don't know, definitely at least a few days. I know my podcasts usually come together within 5 minutes before it starts, but
sounds interesting.
I mean, I haven't done a lot of research on this. I'm just
like random shit off the top of the head.
Right.
And see, that's
I'm just trying to think theoretically on, does this make any sense to me, and why doesn't it?
Yeah. No, I'm cool with that. Even if you wanted to be in there, I know you can be decently respectful. So that's the key. I want to get a couple people in there that want to go gung ho with some facts, because I know a lot of people like to do that. And then I want to see, if you want, think you're, decently logical and want to go against it, that's fine with me too. You know what I mean? I'm fine with that. However it wants to be.
Yeah, for sure. I mean that I could do that for sure. But like I said, I haven't done a lot of research on this. I'm just thinking of my background compared to theirs. They're using all these big terms, but when it comes down to me, it's just it doesn't logically make sense that the further the Earth goes out, causes day and night cycles to be longer in one area and not the rest of the world. That doesn't make sense to me for some reason. It should if the Earth rotates 60,000 miles away from the North Pole, then it should be like a gradual effect from days, the amount of night days you have. It's going to be more in the center, and then it's going to get less the farther you move away from the center, turning into longer day cycles at the edge, was my thinking. But I would
it would still be light outside, even 60,000 miles away. Zunit,
yeah.
Let me pull up. I want a couple of hardball questions. Let me just pull in a little ringer for 20 minutes or so when it's the space portion of the debate. I would love to come on.
Banjo, I'll be glad to have you, man. Of course, dude. Hell yeah.
I don't want to be there for the full thing because I'm legitimately triggered, and but I can hold my composure a little bit when it comes down to the space thing, because it's kind of my jam. And
my whole thing with the whole thing, and I had this whole. I messaged you once before. I don't remember who it was. Somebody typing in Zunit's chat about it after the first time. Is personally, people can, with anything in life, and that's the reason why Zunit was in the military, is because people can think their own beliefs, whatever they want to do. Not saying it's not true, it's true, whatever. But my thing is I don't really care if it's true or false. Why? Because for me, it doesn't really affect me. So people go, oh, well, that just proves the government's lying. Okay, I could tell you fucking that the government accidentally shot down an airliner on the south side of Long Island. And TWA Flight 800. Oh, no, it wasn't fucking fuselage blew up. There's conspiracies with everything. I don't give a shit. Whatever, I like to listen to it because I like to hear people argue. But, like, at the end of the day, like, I don't give a shit if the Earth is flat or round, because guess what? I gotta go to work tomorrow either way.
Exo's next.
Military 'cause we're too dumb for college. That's what we get all the time.
No, dude, we're war dogs, man. War dogs.
We love violence.
Bullet sponges, hell yeah. But yeah, I think it's one of those things that it's also perfect for Twitch. I feel
That's
like
actually what they're talking about in the channel above, Banjo.
I feel like it's perfect for Twitch. There's enough people on Twitch that get really. It's a perfect example of Twitch, actually.
Oh, he's been set free.
Who, Banjo? Oh yeah, Banjo goes. But like how I guess you can say a group of people can listen to one person, one Twitch streamer, and that's the answer. Like, drama is only the drama depending on the streamer you're listening to at the time. You know what I mean? So I can portray something because I have influence to a certain community and make it, fair. Like, say, take an ARC, for example. I can say, dude's cheating, look at this clip. I could play the clip 100 times over because I selected the clip, and then boom. How many people are going to believe they're cheating? A lot of people. And then, what do you know? Like, from then on out, they are now a cheater.
Right.
My influence is there. But yeah, I'm interested to see as well what happens. But I also want to jump into the channel above to see what's going on up there. So, yeah, go ahead. I'll meet you guys up there in a second. All right, Jets. That's it for today. Once again, that was a good, solid refresher from the first one. Pulled into some, other things that we didn't talk about last time. And then, like I said, debate's going to be planned. I'm going to start talking to these guys on setting dates. I think I get a couple people. I'm also going to reach out to a couple YouTube Flat Earth debunkers. And I'm going to see if I can get them on here too, because content creators are content creators. Let's see what they got to say. So let's see if we get them on. We'll, no, don't end the stream. I have to. So just know that there's going to be more like this. We already had one. We had two. I love this kind of stuff. It gets everybody riled up, everybody thinking, everybody doing things. So let's keep doing it and follow the fucking channel. Subscribe if you got it. That's a great way to support it. You know what I mean? Hey, Sellout Sunday. All right, guys. I'm out. I'll catch you guys tomorrow with some captivating gameplay, I'm sure. All right. Later, gents.